Awesome. So, looking at this list of things here, and when you're writing these on your Bellwork paper, you don't have to copy down the question. Like you can say, well, 1, I thought it was A, D, and F. And for 2, just do your work. But I'm not saying that's what the actual answers are. But what do we think? Which of these numbers can't be a probability? A. Why can't A be a probability? Because it's negative. So I'm with you. So this cannot be a probability because it is negative. Anything else? B? D. Does anyone agree with D? 0. Can 0 be a probability?
No, I can't.
Why? Can be nothing.
It could be the probability of nothing happening.
Probability of nothing happened. So what is the probability I roll this die and get a 12? 0. Okay? So it's the probability of something not happening. So it is a probability, it's just nothing happened. C. Why can't C be a probability? It's over 100%. And while that's nice to say in sports that we're giving like 110% or 100.1% in this particular case, mathematically that's not a thing. That's a sports thing, not a math thing. And they're wrong, because you can't give more than 100%, because that would be impossible. Okay, everything else up here can be a probability. We've got decimals, we've got some whole numbers, we've got percents. Those are all fine. Every answer for probabilities for a probability is going to be between 0 and 1. Number 2 here is an old school substitution, which we will see this particular pattern a lot of times. And it's helping us get ready for something in chapter 3. So this particular expression, you will see lots and lots and lots and lots and lots and lots of times between especially now and probably October. In fact, I think there's at least one of those on most homework assignments that I've seen so far. And what we're going to be doing here is we're going to be doing some substitution. So we're going to take each of these values, my A equals -4, my B equals 0, and my C equals -6, and we're going to substitute those in. So wherever there's a letter B, I'm going to put in a 0, and I always substitute things in parentheses. So I've got my B, and then by my expression here, it says B is to be squared. We're going to have -4 times my A, which is -4, times my C, which is 6. And I will substitute it in just like this. Right in this place here, this is why you can see that I put things in parentheses every time when I substitute them in, because there is a big difference between 4 times -4 and 4 minus 4. So I put the parentheses in every single time when we substitute. It stops us from making mistakes on the next step. Because our next step is order of operations. Because we're going to simplify this. I want to get it down to a number. I've got enough pieces here. What are we going to do first, order of operations wise? How do we remember our order of operations? PEMDAS. So I'm going to write it down, and I write it down vertically here. So we've got P, E, M, D, A, S. I always write it like this. So what does the P stand for? Parentheses. Is there anything in my parentheses that I can simplify? No. So we move on with our life. What are we going to do next? Exponents. So do we have any exponents here? Yes. What is 0 squared? 0. We love a challenge part right there. So 0, and then everything else is just going to drop down. We've got -4, -4, and 6. What do we do next? Multiply and divide. These happen in the same step. Multiply and divide, same step, left to right. So we're going to go across this way and multiply left to right. So we have 4 times -4 times -16. So, and if you want to do that, I'm going to bring this up over here. If you want to do it in 2 steps, you can. So we can do it as, now we have 0 minus -16 times 6. You can do it in a couple of steps, or you can do it all in one go. Because our next one is our -16 times 6, which we're going to want to have a calculator for. So we have our 0 minus -16 times 6 is -96. So there's our multiplication and division. We finished that step. Now we're going to do our addition and subtraction. It's the same kind of thing. They happen at the same time. We go left to right. So we've got 0 minus -96. I have 2 minus signs next to each other. They cancel out and it becomes a positive. 2 negatives make a positive. So this becomes our minus. Oop, hello. Why do I have an alarm going off at 7:30? Love that. That's fun. So our negative becomes a positive, and we get 0 plus 96, which means what's our answer here? 96. I've got to try my iPad. Okay. So most of the time we will work all the way through all the Bellwork questions. There may be times when we skip one or have you guys work it independently a lot more. So it is important when you guys come in and get settled that you try these. The point is for you guys to try them and get your brains moving and either review something we're about to do or review something we may have been struggling with. And then we will work through them, but usually fairly quickly. Or I may just hand the iPad to one of you guys to do while I continue attendance, and you will work it through on the board. Ha 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 ha. I won't make you stand up there, but I'll hand you the iPad. Okay, so questions on either of these? So you're just going to hold on to this paper, tuck it in a folder, tuck it in your notebook. It does not have to be in decent condition. You're welcome to fold it and put it in a pocket of something, but you will need it every day, and you will turn it in on Friday, and it will be for points. Okay? It's easy peasy points because most of the time I work them through. So we are going to go into your notes packet from last week. I do still have extra copies if we have anybody that needs a copy still. I got you. Give me 1 second, because I must want to ask you a further question. There we go. Cool. Yes.
Last year I only had like 2. It was from first semester to my work here, study guide.
Half passes over here, but I don't know where. All right.
No, but you wrote.
Yeah,
That was you wrote.
second semester I had this.
You got it.
I think you like which one I got first.
Thank you, I appreciate it. All right. And then to Shay, right? Okay, just making sure I wrote for the right person. All right. So what we have here is a lot of information in a kind of table thingy. It looks like a spreadsheet. These are called two-way tables, and we're going to go a lot more into depth in them in a little bit. But this is an easy place for us to kind of see why the union formula that we wrote last week is kind of as weird as it is. So, we're going to look at this just a little bit, and we're going to find some probabilities here. So we've got information from a survey that was conducted in middle school. And I want to know that if I take all this group of people, I want to know how many people were surveyed. That's my first question. How many people did they talk to? 646. So our total number of people who were surveyed, which it does have that, but it has like no space on your little page, it's 646. How do we know that? It's under total. There's a lot of things under total though, but it is our total, like it's where my totals meet. How many sixth graders did they talk to? 215. How many people did they talk to who ride a car?
131.
131. So the columns are different. The columns are up here. So 131 people riding a car. 215 sixth graders. 646 humans. Yes, middle schoolers still count as humans. You guys were there recently? No? They count as humans. I have a middle schooler. I'm allowed to make that joke. All right, so now what we're going to do is we're going to find the probability. I take this group of 646 people and I pick a name out of the hat. What is the probability that that is a seventh grader?
1/4.
I was going to say, it's not going to be a pretty fraction. I want to know what is the probability if I took this 646 names, put them all in a hat, and I pull one. What is the probability, so we're looking for a fraction here, that this name is a seventh grader?
1 out of 30.
I was going to say, don't try and simplify anything. How are you getting that number?
I don't know.
Okay, blind guess is a fine answer for that. So how many, remember we're doing our favorable outcomes over our equally likely outcomes. How many seventh graders?
220.
220 out of how many people? 646. So how can I make that as a probability?
Divide
220 over 646. They don't have to be pretty. Definitely at least not to start. So we do our favorable outcomes. So that would be my total number of seventh graders, which was 220. Over my equally likely outcomes, my number of humans, 646. And yeah, that'll probably simplify. Both of those are even. We're not going to focus on that right now. We're not going to put these as decimals. We're just kind of getting used to that fractiony thing because it's been a couple of days since we met. Trying to help us reset our brains. And mostly so we can talk about the fourth one. So then I want to know, what is the probability, I go back into this hat where I have everybody, that I pull out someone who is squiggle 8th grade. What does the squiggle mean again? Not an 8th grader.
220 plus 215 over 646.
Perfection. That is an excellent way to do it. Absolutely valid. We can take the things that are not 8th grade and add them together. Option 2 would be to take, all right, I know there are 246 people and I could take away the 211 8th graders. Both Both ways are valid, both ways are equally fine. Either way, so we can either do our 215 plus 220 over our 646, which we will simplify that part. Or we can take 1 minus our probability of 8th grade, which was our 11, excuse me. I'm good at, my eyeballs work so good from this angle. Either way, we're gonna wind up with what?
435.
435 out of 646 humans. So questions on those two. Good warm up from what we did on Friday. Because now I want to talk through the union, because the unions are weird. And this would be, since we haven't gone through a union, this is why homework one's not actually due to tomorrow, because there was a union question on it. I wanted to make sure we did one together. So, union means or. So I want to know the people who walk or are in 6th grade. So I'm going to grab my little highlight tool up here, and I'm going to color the groups we have. I want to know, what is the probability somebody walks or, I'll do purple, is in the 6th grade? So I'm looking for probability of 6th grade and the probability of people who walk. Both. So what is the probability that someone's in the 6th grade? 215 over our 646. That is our 6th graders. How about the probability of people who walk?
30 over 95.
So 30 are the 6th grade walkers.
30 over 215.
95 over 646. Walker. So just the people who walk right now, just the people who walk is this 95. So if I was to just straight up add these two together, just like this, what happened to these 30 people that are in both lists?
Got cut out.
Did they get cut out? Or did they get counted twice?
They got
They got counted.
They got counted twice. So in order to prevent us from counting that group twice, what do I need to do with this 30?
Subtract that.
Subtract it. So if we look at the formula we wrote last week, we actually wrote this down. So I'm going to write this down. So we're going to take away that 30 out of the everybody. It's still over the 646. I don't know why on the green one I wrote 45. There we go. So if we look back to the formulas that you wrote at the very beginning of Friday, I'm going to write and dry erase on the board just because I don't really have a ton of space up here. So for our unions, that's when we had our probability of A plus our probability of B, and we took away the intersection. We wrote this down on Friday. But look what we have here. We have our probability of A, our probability of B, and we took away our intersection. One event, another event, and the intersection. Okay? So it's our way of stopping us from double counting a group. And we will work with this a bunch more when we get into looking at these particular kinds of tables. We're going to spend a whole day looking at these tables and all the things they do. It might be 2 days. I haven't written it on the big calendar yet. Okay, so we will work with these a lot more, but I really wanted us to kind of practice that union a little bit, and when it's in these tables, it's clearest why we have the takeaway part. Otherwise, we're just going, okay, but I don't know what the heck I'm doing. So I feel like this shows it the clearest. But again, we'll go through these tables a lot more in a week. But we're going to practice this a little bit more on the next few questions. That is what it is to see it. Questions on these ones right now? Okie dokie. So we've got a few more that we're going to look at here, just so that we can remember the difference between these relationships. So I want to know where the heck my stylus went. Love that. That's why I have spares. Probably would have. Nope, I did not put it over there. I don't know what I did with it. I love that. That's so fun. I'll find it. Okay, so we're looking at this next set here. I want to know the probability, again, looking at this hat of everyone that I asked a question, 8th grade, and then the upside down one with a car. What does the upside down one stand for again? And. So 8th graders, and they ride a car. So I don't care about the 8th graders who take the bus. I don't care about the 8th graders who walk. Just the 8th graders who have a car, or who ride a car, not have a car. How many 8th graders ride a car? 41. Out of how many humans? 646. So when we're looking at the and, we're just looking at that intersection, where the where the column and the row cross. So our probability is our 41 out of 646. All right, how about our probability of bus? What's the probability somebody rides a bus? 420 out of 646. That happens when I say numbers while I'm trying to write other numbers, it just goes all kinds of wonky. There we go. 420 out of 646. There we go. That's what happens when I try and talk ahead. What is the probability I draw the name of a 7th grader?
220.
The 220 out of our 646. So these tables have a lot of information, but they're not super duper hard to figure out how to read them. Once we get a little practice of it, it kind of, wow, all those bubbles came back. Sorry, ADD went no, I kicked in this morning. All right, we're going to do one more union here. Practicing this, because this was kind of our last piece from last week that we didn't get all the way through, because that was a lot. So now we're doing our union. I want the people who ride the bus or 7th grade. Well, we already know the probability of a 7th grader. We just did that one. So the probability that I'm drawing a 7th grader is this group here. So that's my 220 out of 646. Changing that color just because I already did bus. We also already did the probability that they ride the bus. That was the 2 above that. Probability that they ride the bus is here. And we have our 420 over 646. But we have to watch out, because even though I'm looking for the 7th graders or the people who ride the bus, I need to make sure we don't double count somebody. So what do I need to do? Yes. We have to subtract the intersection, because that 170 kids have been counted twice. So we're going to subtract our 170 over 646. And when we do that, the 220 plus the 420. You can also see when you do one like this, if it's big numbers like that, if I added those together, we'd get 640. And there's not 640 people out of 646 people in the pink and green highlighted section. I have a lot more than 6 people outside of it. So it's really, on big numbers like this, it's easier to spot if we forget to do the subtraction part. But either way, what do we get as our numerator? Say it louder.
470.
Sounds about right. I never simplified mine in my notebook, but that's okay. 470 out of 646. questions on this one? Because we're going to walk away from these kind of tables for a while. We will come back to these tables later in the week when we will do a whole lot with them. I think that'll be Wednesday. No, Wednesday's class meetings should be Thursday. I'll get the calendar up there and it'll have the whole chapter up there. I got everything fixed over the weekend because I didn't like the way it was. Okay, so what we're going to talk about now are frequency tables. You have probably seen these before, but again, it's been a hot minute. It's just a list of our data. So this is talking about our hours slept, and these were the answers people gave. And then when it says frequency, what that means is the number of people who answered that. Or the amount of data that we got from that. It doesn't have to be people, it could be the number of times we flipped a coin, or the number of times we rolled a dice. Sorry, all my references will be dice heavy. Gen Con was this weekend, and I got so many new dice. So my first question here is, if we're saying that that frequency column, that's the number of people, how many total people did they ask about their sleep? 15. How did we get that? Add up this whole column. 1 plus 3 plus 5 plus 2 plus 1 plus 1 plus 2. So we had 15 total people that we asked.
There's some.
Hey, oh, yes, I forgot to turn the sign. There's a sign there that says don't disturb. So if we had 15 total people that were included, that's this column. So now we're looking at our data value. What is the minimum data that they got? 6. That means the minimum means the smallest. So this is smallest of whatever data we had. So the person who slept the least, I did not mean to cross that out, the person who slept the least slept for 6 hours. Because that is our smallest data. And if it helps, you can rename this as to your data. So similarly, what is the maximum data value? 9, maximum being the biggest. We will use the words minimum and maximum a lot of times this year. We'll talk about those in all kinds of different graphs, in different shapes, in different segments, different pieces and tables, all kinds of stuff. So we'll use minimum and maximum a lot. When we're writing things, I'm 100% okay with you abbreviating them to min and max. The sheer amount of M's and U's is annoying. So that's just kind of a basic reading of this part, looking at minimums, maximums, and frequency. We're going to do probabilities in the next step, so I want to make sure we understand what's happening. Questions on this part right now? What was it? Okay. I would say, if you have questions, absolutely fine, and if it's that we don't know what we don't know yet, and you have a question for this later, totally fine. Absolutely fine with that. I am all about the questions. So let's do probability here. What is the probability that someone slept for 6 hours? 1 out of 15 people. Gorgeous. What is the probability that someone slept for 6.75 hours?
5 out of 15 or 1/3.
Yeah, 5 out of the 15 people that got the 6.75, this guy, out of the 15. So we can simplify that. Both of those divide by 5, which means we can put this as 1/3. I heard a lot of you notice that, which is fantastic. And then what is the probability someone did not sleep exactly 8 hours? 14 out of 15, because only one person slept exactly 8 hours. So we have 14 out of 15 people. we've got 5 minutes. We gonna enter the next thing. We'll probably finish it up tomorrow, but I want to make sure we get there. So we're gonna look at page 5, and we're gonna talk about something called the fundamental counting principle, which you probably don't know the name for, but you already do, because it's all about how many options we have. And it has a very mathy way of having a definition. And I'm going to write it, but you write down what works for your brain, okay? So it says, if there are n, so we're going to use the letter n, ways to do something, and m ways, so different letter, to do another thing, which that's my favorite phrase in a definition, because it's so vague. Then, we're almost there. There are n m ways, I'm running out of space, to do both, which is a super complicated way of figuring out something we already know how to do. Because this example right here will make this a lot clearer. I feel like the example helps way more than the definition. If you have 4 shirts, 2 pairs of pants, and 3 pairs of shoes that you're packing for vacation, going for capsule wardrobe here, how many different outfits can we create?
4.
Well, I've got 4 shirts, so I could use shirt 1, shirt 2, shirt 3, or shirt 4, right? With each of those shirts, I could use one of 2 pairs of pants. Maybe I've got sweatpants and jeans, or sweatpants and jeans, or sweatpants and jeans, or sweatpants and jeans. How many different outfits do I have right there?
It's still 4.
2,
Well, no, I got 1, 2, 3, 4, 5, 6, 7, 8. Man. 8. But also, we could do that as 4 times 2. Same 8. So now if I have, let's say, sandals and hiking boots and sneakers, 3 pairs of shoes. So I could take my, let's say this is a pink shirt and my jeans, and I could either go with sandals or hiking boots or sneakers. I could take my pink shirt and my sweatpants and go sandals, hiking boots, or sneakers. So that gives me now this 2 outfits turned into 6. Same thing here. Same thing here. So how many total outfits could I get from 4 shirts? Yeah, 4 shirts, 2 pairs of pants, and 3 shoes. Without having to draw this whole picture out, because what if we had 20 shirts? What if we had 12 pairs of shoes? What we have is we have our 4 shirts times our 2 pairs of shoes times our 2 pairs of pants and our 3 pairs of shoes. There we go. So we'll have 24 outfits. So all we have to do is figure out how many pieces there are and multiply them together. Okay? We'll stop there. We will go through a couple of these tomorrow. They're not more complicated than the outfit. Like, that's as much as they go. I am going to pass out homework 2. I know homework 1 is not technically due yet. Homework 1 is due tomorrow.
Which homework 1?
That's the one I passed out on Friday. But because we have we'll have class meetings on Wednesday. That's gonna play games. I won't miss. I don't know that any of you guys will wind up, but I do have one class where I lose almost everybody, and I don't want us to have to push ahead in that or like be behind in that class. So I'm gonna pass it out. I will make sure to put all the due dates this week, but they're gonna be a little wonky because I'm trying to make sure nothing's due when someone's in a class meeting. So I'm still want to make sure we have 2 days. So this is not going to be due until Thursday because of class meetings. Okay? So this week due dates are gonna get a little wonky, but I'm trying to make sure nothing is due on a day when someone's not gonna be in my class for me to remind them that it's due. Yes. So here's Alright, so there's homework 2, and it says at the top here it's homework 2. And I know I had a few friends who needed another copy of homework 1.
This was the people will always be outside.
Homework 2, did I not bring it up? Love that for me.
Everybody's always gonna be always better.
Alright,
Okay.
homework 2. Calculators are back here, they have back here, flag. Oh, guys, forget. Skip your. That's homework 2, that's what I just said that.
Look, it's telling me each class is.
I was here. Alright. We do have a bunch of announcements, and at this point, y'all have to listen to me read them to you because you're surely not sick of hearing me talk yet. Once we get RDTV, it will come up on the announcement page, but we don't have that yet. So, freshmen interested in playing football, please plan to stay after school Monday, August 5th, and meet at the football stadium at 2:45. Pike men's soccer tryouts are Monday after school at 2:40, so today. Student Leadership Council will have a call-out meeting today from 2:30 to 3:30. See Mrs. Williams, Miss Buckley, or Miss Enlow for questions.
She's going back there.
Girls Track or Field has a call-out meeting K106 Tuesday. Do you like to sing, dance, act? Consider auditioning for SpongeBob the Musical. Call-out meeting held Wednesday in D102. Go to D102 for more information. Pike Key Club has a call-out meeting on Wednesday from 2:30 to 3:30 in the Media Center. We will have rides at the high school main entrance at have rides available at the high school main entrance at 3:30. So have your own transportation home. Pike High School Back to School Night is Tuesday, August 13th, starting promptly at 5:30. Doors open at 5:15. Families follow your schedule in 10-minute intervals to talk to teachers. Financial Aid Night is August 14th at 5:30 in the high school cafeteria. Join Pike Gender Sexuality Alliance, trying to make sure I get all the pieces in the right spot, PGSA, for their call-out meeting August 15th at 2:30 in the PHS Media Center Vonnegut Room. Pike Robo Devils team has their call-out meeting August 16th from 2:30 to 4 in D144. Make and drive robots. And then any new or returning athletes who are interested in swimming or diving should attend the preseason call-out meeting Wednesday, August 21st at 2:40. Have transportation here by 3:45. 3:35. A lot of announcements, and I've got them with more tomorrow. All right, that's all the things.
Can't see you. Unless y'all.